All right, have a look at this. It might not look like much, just a simple, kind of cryptic drawing, but what if I told you that this is the fundamental blueprint for our entire modern world? Let's crack this thing open and see how. This is it. A few lines, a couple of symbols, and that's it. But this little schematic represents a concept so powerful that it's embedded billions and billions of times over in pretty much every single piece of electronics you own. It's literally the silent engine that runs our world. So what on earth is this thing? What does it actually mean? You know, it kind of looks like a secret code, and today we're going to crack it together. Okay, so to understand the whole picture, we got to start with the individual parts. We're going to break down this map symbol by symbol and learn the basic language of electronics. First things first, power. You can't have electronics without, well, electricity, right? So these two symbols here, on the left and the right, those are our power sources. You can just think of them as the batteries that make everything else work.
Now for the main event. Look at that component right in the middle. The circle with the three little connections. That is the star of the show. It's called a transistor, and honestly, this little guy is the invention that changed, well, pretty much everything.
And finally, let's look at the flow. You see these labels, IE and IC? They're showing us the path of the electrical current. IE is the input signal coming into the transistor, and IC is the output signal going out. So something comes in and something different leaves. The big question is, what's happening in between?
To really get what the transistor does, we're not going to get bogged down in complex physics. Instead, let's use a really simple analogy. Think of it as a kind of valve.
Now, the formal definition is that a transistor is a semiconductor device used to amplify or switch signals. But forget the jargon for a second. The key word, the magic word here, is amplify, which just means to make something stronger. Let's see how that works.
Imagine a simple water faucet. You've got the main pipe with all the water pressure behind it. That's the emitter. Then you have the spout where the water comes out. That's the collector. And the knob you turn, that's the base. Now, with just a tiny, effortless twist of that knob, you can control a huge, powerful flow of water. While the transistor does the exact same thing, but instead of controlling a flow of water, it's controlling a flow of electrons.
And that right there, that's the magic of the transistor. Just like a small twist of the faucet knob controls a powerful stream of water, a small electrical signal can control a much, much larger flow of electricity.
So, a weak input signal goes into the base. That's our tiny twist on the faucet knob. This little signal controls a much larger flow of power coming from the battery, creating an output signal that's a bigger, stronger, amplified version of the original.
Now, the crucial point here is that the circuit isn't creating energy out of thin air. It uses that small input signal to shape the raw power from the battery into a new amplified signal. It's all about boosting its power. And this is a huge deal. I mean, think about it. Signals from a satellite, a radio tower, or even just through a long cable get weaker and weaker the farther they travel. Amplification is what turns those faint whispers back into clear voices. Without it, technologies like radio, television, and computers, they just wouldn't exist. So, let's connect all the dots. How does this one simple diagram become the engine that drives so much of our digital world?
Well, this fundamental principle of amplification powers every single one of these technologies, from the faint radio signal your phone catches to the complex calculations happening inside a computer chip. It's all driven by countless tiny circuits just like the one we just decoded.
And when I say countless, I really mean it. A single processor chip in the phone you might be watching this on contains over 100 billion of these transistors. That's more transistors in your pocket than there are stars in our galaxy. It's just mind-boggling. And each one acts as a microscopic amplifier or a switch, all working together in perfect harmony. So there you have it. We went from a mysterious diagram to the very engine of the modern world. You now know how to read the blueprint. So the next time you pick up your phone or use your computer, just think about that. How many billions of those tiny little engines are firing away, just for you, at this very moment.